Pre-calculus 4.6 day 3. We're going to be learning about secant and cosecant today, but we have a little warm-up with tangent. And the first thing I want to do is make use of structure and pull out the 2. And when you pull out the 2, it's actually multiplying the pi force by 1/2, the reciprocal. And that helps us find our phase shift. And since it's tangent, the period is pi divided by b, and b is 2. The key increment is 1/4 of your period, and so your key increment is pi/8. And there isn't a blank for it, but your phase shift is going to be to the left pi/8. And the nice thing is that the key increment and the phase shift agree. And so we can just grid it out by pi/8. So pi/8, 2 pi/8. For tangent, I go 2 key increments to the right. This is before phase shift. And I have an asymptote. And I go 2 key increments to the left. Again, before phase shift. And there's an asymptote. And at 0, tangent is 0. And then since there's a vertical stretch of 3, we would be at 3 here, 0 here, and at 3 here before phase shift. But now we're going to move everything to the left, pi/8, which is nice since that is what 1 unit is. And so we end up moving the asymptote pi/8 to the left, so that's -3 pi/8. And this to the left one. So that's at pi/8. And then we need to take each of these and go 1 unit to the left. And remember, it needs that change in concavity, so I kind of go parallel to the x-axis before pulling away a little bit. And then they want it for 2 periods, so repeat the pattern. -3, 0, 3, and then another asymptote. And those are going to, let's see, we have 3 pi/8, 4 pi/8, and 5 pi/8. So my x-intercepts are at -pi/8 and then at 3 pi/8. Again, the distance between those should be equal to your period, and the distance between those is pi/2. Same with the asymptotes. You have at x is -3 pi/8 and x, don't forget the x equals. If you don't have that, they will be counted wrong. So x is pi/8 and x equals 5 pi/8. Any questions? All right, now for secant and cosecant graphs, what happens is if we have the sine graph, then cosecant is the reciprocal, and sine starts at 0, and there's approximately what 1 period would look like. Well, for the cosecant graph, since it's the reciprocal, they meet up where sine is 1 and -1. But the reciprocal of 0 produces asymptotes for cosecant. And then they meet up at the 1, and then the cosecant has kind of a parabola-looking thing, but it's not a parabola because it never gets wider. It starts getting closer to the asymptotes, never touches, never crosses. And you have one scoop up, and then you have one scoop down. And that's what a cosecant graph looks like. So what we're going to do is focus, when it's cosecant, on graphing the sine with the period change, amplitude change, phase shift, shift up or down. And then we're just going to put asymptotes where sine would be 0 and do the kind of parabola thing, opening up and opening down. That is one period for cosecant. And then we look at y as cosine. And we typically, for graphing secant, start to the left where cosine is 0, which is negative pi halves. And then cosine is 1 at 0. And we go to where it's, 3 pi halves. And so at negative pi halves for the secant, we have an asymptote, positive pi halves, and at 3 pi halves. And then where cosine's 1 and negative 1, that's the place where they have the same value. And we have this scoop up and this scoop down. And that's one period of secant. So that's kind of what happens with these. So let's try it on the graph. For sine, the period is 2 pi, and the key increment is pi halves. And so we're at 0, pi halves, pi, 3 pi halves, and then 2 pi. So sine goes from there to 1, to 0, to negative 1, to 0. And I'm just going to dash that because ultimately the goal is to graph cosecant. And so where sine is 0, if you do the reciprocal, you get asymptotes for cosecant. And then the cosecant graph is actually, we just scoop it up from positive 1 and a scoop down from negative 1. And that is one graph. And then we just repeat that pattern. So we have 5 pi halves, 3 pi, 7 pi halves, and 8 pi halves, which is 4 pi. And so the sine would continue to go up to 1, down to 0, to negative 1 to 0. And where it's 0, we have vertical asymptotes. And where it's 1, they meet. And there's the graph of cosecant for 2 periods. So for cosecant, you end up with asymptotes at x equals 0, x equals pi, x equals 2 pi, x equals 3 pi, and x equals 4 pi. And there are no zeros since there's been no shift up or down. Now, for cosecant, the domain is all reals, except, and then we have to find a way to write out how this happens. And it is when x equals pi n, and this is read n is an element of the set of integers. And the set of integers is 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. And so what we do with the n, 0 times pi gives me 0, so I get x equals 0. 1 times, when n is 1, I get the 1 pi. When n is 2, I get the 2 pi. And it would continue to the left with negative pi, negative 2 pi, negative 3 pi. And so this symbol right here means is an element of. And z is the set of integers. So all of this, n is an element of the set of integers, and that's, if I replace n with those values of integers, I get these produced. Now for range, and I don't know, I'm just going to put it up here. Range, it goes from negative infinity to negative 1 inclusive, and then union 1 to positive infinity. There isn't any values for cosecant between negative 1 and 1. All right. So then for cosine, the period is 2 pi, and the key increments every pi halves. And so that's going to be the same for the secant. But we typically start at negative pi halves because at negative 90 degrees, cosine is 0. So we can start on an asymptote. And then cosine goes to 1 to 0 to negative 1 to 0. And so this is at your pi halves, pi, and 3 pi halves. So your cosine graph would look like this. And then for the secant, it's the reciprocal of cosine, where cosine is 0. When you flip it, you get it 0 in the denominator, which is not possible, so you get asymptotes. And the one value that they agree on, where they meet up, is at 1, because the reciprocal of 1 is 1, and at negative 1, because the reciprocal of negative 1 is negative 1. And then, I didn't talk about it for the sine, but when cosines from here to here, you have values between, its height is between 0 and 1. And when you flip values between 0 and 1, they get bigger than 1. And so as I'm going to here, the reason why secant goes to positive infinity is because those values are getting closer and closer to 0. And if you have, say, 1/10, the reciprocal of that is going to be 10. And if you have 1/100th, the reciprocal of that's going to be 100, and et cetera, et cetera. So as this goes to 1/10th to 100th to 1/1000th, the reciprocal is growing without bound to positive infinity. And so that is why the secant just starts going up astronomically. It's just going way high. As cosine's approaching 0, its reciprocal is going to positive infinity. And then over here, it's just that they're negative values. So you're getting negative 100, negative 1,000. And then just continue that for another period. Cosine would go to 1 to 0 to negative 1 to 0. You'll have asymptotes where cosine is 0. And then they will meet up at 1 and negative 1, and so this is a second period. of secant. And so values at 2 pi, 5 pi halves, 3 pi, and 7 pi halves. So your asymptotes are at x equals negative pi halves, x equals pi halves, x equals 3 pi halves, x equals 5 pi halves, and x equals 7 pi halves. And the distance between them is half of your period, because you actually get an asymptote in the middle of the period. So since the period is 2 pi, you start with this one and you add pi to it to get to the next one. And that has how we can talk about the domain. The domain is all reals except, and I know this is, the first time you're seeing this, but it's good exposure for some stuff that's coming up. What we do is you can pick the value of any asymptote and set it x equals. So we'll start with negative pi halves. And then what you have to add to get to the next one is half the period, which is pi. So I need to add to this multiples of pi. And so negative pi halves plus pi n, where n is an element of the set of integers. So that's the first time you've really probably been exposed to repeated things we have to skip. And there's an infinite number of them. So we have to use variables to represent them. And then the range. The range is the same as it was, for cosecant. So there it's graphed for 2 periods. So let's flip it over to the back side. And so now what you want to do for these is you want to graph its reciprocal function. We want secant, the reciprocal of secant is cosine. And we want to make use of structure, pull out the 3. And we have a plus 1. So we're going to start by doing all the things that we did to graph cosine. And we're just going to dash it. And there where you hit the maximum and minimums, secant will meet up and have a scoop up and a scoop down. So for cosine, the period is 2 pi divided by b, which is 3. And the key increment is 1/4 of that, and 1/4 of 2 pi thirds. 2 can go into 4 2 times, and you get a pi 6. And the phase shift is right to pi 6. Which is nice because these two agree. And so we can grid it out by pi 6. And for cosine, we're going to go to that left, the pi 6, right pi 6, 2 pi 6, 3 pi 6. And since there is a vertical stretch by 2, cosine would start at 0, go up to 2, back to 0, down to -2, and back to 0. And since we have to do it for 2 periods, I don't know if you want to add another period right now. And that would be at 4 pi 6, 5 pi 6, 6 pi 6 is pi, and 7 pi 6. But now we are going right pi 6, and you have, you need to go, you have a vertical shift of up 1. So each of these points need to go to the right pi 6, which is 1 unit, and up 1. And we have a new midline. My midline is y equals 1. And that's going to be important because that is acting as the x-axis, and we have to see where cosine touches that to know where our asymptotes are. So take each of these points and go to the right one and up 1. Oops. To the right one and up 1. To the right one, 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 up. 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 And so the cosine, not that you have to draw it in here, but it might be helpful to you. And then it is at these places where cosine hits the midline that were the zeros. And that's where you get your asymptotes. That's why drawing the midline is helpful. And so you're going to have an asymptote at 0, at 2 pi 6, at 4 pi 6, and at 8 pi 6. And then your secant graph meets up at the max and the mins. And then you have a scoop up between the asymptotes and a scoop down. All right, and then your asymptotes are at x equals 0 and x equals pi thirds. 2 pi 6 is pi thirds. And let's see, 4 pi 6, which is 2 pi thirds. And at pi. And at 4 pi thirds. The distance between them should be half of your period. And half your period is pi thirds, so you're going by pi thirds. And there are no zeros. And so for the domain, it would be all reals except you pick any of the asymptotes that you want. So if I pick 0, and then you multiples of half of the period, because the distance between them is half the period. The period's 2 pi thirds, so half of the period is pi thirds, and that's times n, where n is an element of the integers. And you actually could, simplify that to just pi thirds n if you wanted to. And then the range, you just have to look. It's going up to -1, negative infinity to -1. And it's up at 3 and going up to positive infinity. Okay, and so your ability to graph secant, cosecant are dependent on your ability to graph sine and cosine. And so for the next one, the reciprocal of cosecant is secant. Or I'm sorry, the reciprocal of cosecant is sine. And the b is just 1, so there's not a period change. But you're going to be shifting left pi fourths and going down 2. So the period is 2 pi, and that means my key increment is pi halves. But you're going to be going, your phase shift is left pi fourths. And so you need a common denominator between your key increment and your phase shift. And so the key increment is 2 pi fourths. And you want to grid it out according to their small common unit, which is a pi fourths. And you're also going to have a vertical shift of down 2. So for your key increments, you want to go by pi fourths. And for this one, we're just not going to get 2 full periods on here. We're just going to do it for 1. And sine starts at 0. And remember that the key increment is 2 boxes. It's 2 pi fourths. So you have a reflection in the x-axis and a vertical stretch. And so you would be at -2 at the 2 pi fourths. You'd be at 0 at pi. 6 pi fourths, you'd be up at 2. And 8 pi fourths, you'd be at 0. And you have a midline at y equals -2 because it's dropping down 2. So it's kind of helpful to have that in just visually, because it's where the sine hits that midline where you're going to have asymptotes. And now we're going to go to the left pi fourths. So 1 unit left and down 2 for each of these. So this point's going to the left 1 and then down 2. And we need to do that to each point. So to the left pi fourths down 2 puts a point here. To the left 1 and down 2 puts a point here. Left 1 down 2. Left 1 down 2. Left 1 down 2. And here would be your shifted, reflected sine graph. And where you hit the midline, where you hit the midline is where you're going to have your asymptotes. So we're going to have an asymptote -pi fourths, 3 pi fourths, and 7 pi fourths. And where you have your max and mins on the sine is where they're going to meet up. And so your asymptotes, x equals negative pi fourths, and then half the period away from that is where your next one's going to be. And half your period is pi. If I add pi to that, I'm at 3 pi fourths, and that's where it is. Add pi to that, and we have 7 pi fourths. And so that means your domain is all reals except, and you just pick one of those asymptote values, and then take the distance between them, which is half of your period, which is pi, times n, where n is an element of the set of integers. And that's your domain. That will get you skipping all the asymptotes. Again, this value is half your period. And this is any asymptote value. And your range, you just have to look and what's the lowest point? It's -4, so negative infinity to -4. Union, whoops, inclusive of -4. Union, and then 0 to positive infinity. In this case, you could say you have an x-intercept at 5 pi fourths. And that's the end of the lesson.